Welcome. In this video, we're going to continue looking at right triangles and how we can use the Pythagorean theorem to help us find a missing side length for these right triangles. The biggest thing we should have started to understand yesterday is that the Pythagorean theorem is a formula which helps us find the missing side length for right triangles. So if we see a right triangle and if we know two of the side lengths, this formula, a squared plus b squared equals c squared, helps us figure out the missing side length. Important vocabulary to know: right triangles are any of the triangles that have a 90-degree angle. You'll see a little box like this. And a new word, hypotenuse, refers to the longest side of a right triangle. In this case, and always, it's going to be C. For this right triangle, the blue side, C, is the hypotenuse because it's the longest. This is important because for our formula, we need to know which letters, A, B, and C, correspond to which side lengths of the right triangle we're working with. A and B are called the legs. They're the two shorter sides that make the right triangle. And C is the hypotenuse. That's the longer side. It's always going to be facing opposite this right angle here. Towards the end of the video, we'll talk about how c squared minus a squared equals b squared is a different version of the Pythagorean theorem. It's just transformed, and it's more helpful for triangles like the red one compared to the blue one. First, let's take a look at this blue triangle. We are given a right triangle. We know that from the right angle. Two side lengths of 40 and 30. We first want you to pause the video and think about which of these three side lengths is going to be the hypotenuse, or C. Welcome back. Hopefully you realize that the hypotenuse for the blue triangle is this long side here that we don't know. I'm going to go ahead and put the C right there to let myself know this side, the unknown, is C. That means that the two shorter sides, the ones that we do know, are going to be A and B. A and B are interchangeable. It doesn't matter which one is which because they're both going to get added together after we square them. Now that I've labeled my right triangle and I understand what the hypotenuse is, it's C, I'm going to be plugging in for A and B into my formula. So I'll take my formula, replace A, this is substitution, with 30 because that's what it's equal to, and I'm going to replace B with 40 because that's what it's equal to. You'll see we need to make sure that both 30 and 40 are still squared because that's what was happening in our formula with A, B, and C at the beginning. Now, 30 squared, I could use a calculator to figure out that that's 900, but hopefully we know that 3 times 3 is 9, so that tells us that 30 times 30 would just give us 900. 4 times 4 is 16. That means 40 squared is 1600. So our formula becomes 900 plus 1600 equals c squared. Pause the video and try to finish this problem. Welcome back. The first step, which you all should have seen, we need to add 900 and 1600. That gives us 2500. So our equation transforms and becomes 2500 equals c squared. The last step that we need to perform here is we need to somehow get rid of this exponent of 2. We need to do the inverse operation of squaring c. And the inverse operation of squaring c is to take the square root. So on both sides of my equation, I'm going to apply a square root. The result of this, the square root of c squared, is just c. C is the number squared that would give us c squared. The reason we did the square root is to get rid of that squared. We see why that works. That means we have to do the same thing to both sides. The square root of 2500, I'll first put it into a calculator. Square root of 2500 gives us 50. Another thing I could understand, if the square root of 25 is 5, maybe that would help me see 50 times 50 is the number that would give me 2500. Now, I always want to check my answer, see if it's correct. So I'm going to go ahead up here and I'm going to plug in a 50 for C. C equals 50. And I'm going to take a look. Does it make sense for C to be 50 here? Sure, this side's 30, this side's 40. This is our longest side. It should be a bit bigger than 40. 50 is a bit bigger than 40, but it's not gigantic. It's not ridiculous for a number. The second example we're going to take a look at is this red triangle. Why don't you pause the video and try to work through and figure out what the value for this missing side length is. Welcome back. Hopefully the first thing you did is label your right triangle. We'll see the red triangle is a bit different. This time, the hypotenuse, the longest side, is 8. We already know the hypotenuse. That means the two legs, A and B, are 6, and the unknown value, I'm going to go ahead and label this one A, this one B. Like we said, they're interchangeable. You could do it either way. But this time, I know the long side, hypotenuse, and I'm trying to find the short side, the leg. Hopefully you then plugged into your formula. One option is to use a squared plus b squared equals c squared. So there I would replace c with 8. And this time I would replace a with 6. We don't know b this time. We're trying to solve for it. So 6 squared gives us 36. We don't know what b is. That's the side length we're trying to find here. And we know that 8 squared, 8 times 8 gives us 64. Pause the video again. This equation's a little trickier. Can we add the 36 and 64? How are we going to solve for b? Welcome back. Hopefully you remember from Mr. Neville, Miss Forts, Miss Ogagwa, that to get the 36 on the same side of the equation as 64, we need to subtract 36 from both sides. I want to isolate the b squared, or as Mr. Neville would say, start peeling the onion. So I need to get rid of the 36, the term that's on the same side of the equation as b squared. I use an inverse operation. I subtract 36 to do that. When we do that, all we're left with on the left side of our equation is b squared, and 64 minus 36. 64 minus 30 would give us 34. Take away 6 more and we're at 28. If I wasn't sure, I could go ahead and use a calculator to check that 64 minus 36 is definitely 28. Our last step, as you should remember, every time to finish the Pythagorean theorem, we need to get rid of the squared that's attached to the unknown side length. The way we inverse operation a squared is to do a root or a square root. So the square root of b squared would cancel out the exponent and leave us with just b. We need to do the same thing to the right side of our equation because anything we do to one side, we must do to the other. That leaves us with b. And when we do the square root of 28, we see we get an irrational number. This is one of those numbers that's not a perfect square. Whoever asked the nearest hundredth, that's to 2 places. So if the answer is 5.2915, the dot 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 lets us know it keeps going. The nearest hundredth would be 5.29. The nearest thousandth would be 5.292. The reason for that, the nearest thousandth, means we go to 3 decimal places. But I need to look at the number that comes after. If it's 5 or bigger, I need to round up. That's why to the nearest thousandth, the answer would be 5.292. If we plug that number up in here for b, 5.2, we see that that's pretty reasonable. It's just a little bit shorter than the 6, just like we would expect.